Metal foam for batteries is important in two different cases. We have closed cellular foam and open cellular foam with different applications. Closed cellular foam is important for lightweight design, so you can create houses, boxings for the battery. And the open cellular foams are important for the heat transfer, so you can use the large surface of the foam and have an easier heat transfer in a cooling liquid. Metal foam needs to be taken into account already in the design phase of the battery component. It can be like in the battery housing. And it's always a question when you have a structure and you try to integrate a component like metal foam, it gets heavier and not lighter. So adding a material will always bring more weight, and we want to create lightweight design. So in this case, we have to take it into account already in the design phase and adapt the application already to the future parameters of the foam. It's very light, it's very stable. You have flow influence, and this way you can make a positive effect for the design already in the beginning of the project. Simulation, the most important bit of simulation is that we work on two different topics. One is the flow of the cooling liquid through the cooling element, and the other one is the heat transfer from the electronic component into the cooling liquid. And that needs to be simulated and optimized, and we work especially on those parameters to find the optimal way how to transfer the heat from the heat source into the cooling element to cool our battery components. When we recognize the flow of the cooling liquid in the electronic component or in the cooling element for the electronic component, we found out that the stochastic foam is always a compromise for the structure. So you have hot spots on some places and cool spots on others. So the structure should look different on one place than the other. So to optimize this flow of the cooling liquid, we actually optimize the foam where the cooling liquid is running through. So by the load case, we take an infrared picture of the load case or simulate where the heat sources are, and we optimize the structure of the metal foam in a way that the flow is influenced and cools on each place in an individual and adapted manner. So this way we have an optimized and best possible cooling element, and that will be the future to have the most efficient cooling element you can get. There's one demand that is growing because the density of electric components is always getting higher, so it's getting closer and the heat sources are getting hotter, and you can only reach the next level of performance when you cool in the most appropriate way. And with those individualized cooling elements, you will achieve that.